Hey everyone, I'm Akash Joshi. I'm the operations research guru, and today we're going to be taking a look at Google's PageRank model. And basically, this is the way by which Google determines how to orientate their web results when you search for something. So, which link or which website should show up first, second, third, and so on. So, basically, ordering it by importance. So, this is kind of the simplistic model of how Google actually creates this list. So let's jump into it. So first, let's take a look at our model. We have a matrix G, which is equal to P times this matrix plus 1 minus P times this matrix. And if you notice, the matrices are n by n matrices. So if we have n websites, if we have 10 websites, let's say, then the matrices are going to be 10 by 10 websites. Or sorry, 10 by 10 matrices. Okay. So each column of this P star website over here corresponds to a specific website. Each column of P star is also a probability vector representing the links to other sites. If you don't understand what these two concepts really mean, then don't worry, because we're going to look at an example and you'll understand after we go through the example. K is a matrix with all elements equal to 1 over n. So if we have 15 websites, then K is a 15 by 15 matrix with all elements equal to 1 over 15. P is a dampening factor, typically 0.85. We don't really know what Google uses for their dampening factor, but it's suspected that it's 0.85, but we're not too sure. Usually problems will tell you beforehand what dampening factor to use. And that's our first equation. Our second equation, once we get G, we have to solve for GQ equals Q, and Q is a vector. So once we get Q, the highest value element in Q is the website that has the highest importance, and that will show up first on the web browser. So the highest value element gets PageRank 1, the second highest value element gets PageRank 2, and so on. Okay, let's look at an example problem. So over here we have 5 websites, A, B, C, and D, and E, and they all link up to each other like this, as our diagram shows. So here is our model. We have 5 sites, as I mentioned. So P and K are going to be 5 by 5 matrices. P star, let's look at P star first. So let's first take a look at website A. If you notice, website A only links up to website B. Sure, it links up to B and C like this as well, but website A contains a link that only goes to B. So that's why we're going to put a 1 here and zeros everywhere else. Okay, and then we go to website B. Website B has a link to itself. It has a link to website A, it has a link to website C, and it has a link to website D. So those are 4 total links. So we're going to do 1 divided by 4, 1 divided by 4, 1 divided by 4, and 1 divided by 4, because these are the websites that they link up to. B does not have any connection to E, so we're going to put a 0 there. And let's look at website C. So C links up to A like this, and then C also links up to D like this. So we're going to have a 1/2 in the A row, and then we're going to have a 1/2 in the D row. Okay, let's take a look at website D. D links up to C as well as E, so we'll have a 1/2 in the C row and a 1/2 in the E row. And E actually does not link up to any other websites. There are no forward arrows that come out from E and connect to any of these other websites over here. So what we're going to do is we're just going to do 1 over 5s across the board. So basically what that's saying is that from this website, a user has a 1 in 5 chance of going to any of the other websites. And then of course we have our K matrix over here. Since there are 5 sites, all the elements of this 5 by 5 K matrix are going to be 1 over 5. Then we have our G matrix, which can be solved using our model. P times P star plus 1 minus P times matrix K. P I set to 0.85, and after you evaluate this equation, you get this complicated matrix over here. That is G. Okay, now let's get into actually solving for the importance vector. We can rearrange this Markov chain into GQ minus Q equals 0. We can factor out the Q, and we get G minus the identity matrix for a 5 by 5 matrix equals 0. Okay, let's look at our actual solution. So this is a G, and we're subtracting from the identity matrix as we said over there. Multiplying by this vector over here should give us 0. This is what's in the brackets, and we get Q equals times Q equals 0. So now we need to solve for the elements of Q, and you can enter this into the Desmos matrix calculator as an augmented matrix, which is what I did, and you get this right here. And basically what this is saying is that this is the most important site, so website B, and then A, C, and D are equally important, and E is of little importance. So that this is the order in which websites will show up when you search for something. B will show up first, A, then C, then D, and then E. Well, A, C, and D are interchangeable, so we need some sort of tiebreaker to determine which one to put first, but a more complicated model with more websites would typically solve this problem. Okay, that's it for this video. I hope you learned how Google does their Google PageRank algorithm. Thank you for watching. Goodbye.